Welcome to Made in Science, the official podcast of the University of Stuttgart. Today, our guest is Dr. Luiz Chamon from Brazil, who came to the University of Stuttgart in 2022. He has his own research group at the Cluster of Excellence SimTech and ELLIS. His research areas cover optimization, constrained learning, machine learning, signal processing, dynamical systems and control, and statistics. In our conversation, we will hear about different forms of learning, some of his international experiences, music in his life, and what it's like living next door to ELLIS. Hello, Dr. Chamon, and thank you for visiting us.
Hello, thank you very much for having me in this snowy day, Stuttgart. Yeah.
You described yourself not as a mathematician and also not as a physicist, but as an engineer. How do you draw the distinction? I would assume there is some overlapping happening between these different disciplines, but perhaps you can elaborate that a little more, how you combine the different influences, at least, in the work that you do, in the theoretical orientation that you have in your research. What influences do you operate with?
Yeah, that's a very tough question because I don't want to step on any mathematicians or physicists' toes. So thank you for starting with the hard ones. I completely I have to resonate what you said. I think there is a lot of overlap between these areas, and nowadays more and more, I think that the boundaries between fields have been blurred, and I think this is, to a large extent, very positive development that has been happening. I always joke that I'm more of an engineer than any other type of let's say of STEM. Let's say that I am more in the E part of STEM, because really this is where I grew up, right? So I am an electrical engineer by training, and that means I think that to a certain extent we see problems a little bit differently because of historically where engineering is. And I think that most importantly for engineers, the main thing that let's say the part that comes out more strongly in engineering is really the idea of working with requirements. So with the problems that we tackle in engineering are really based on these setting requirements towards the solution that we are looking for. And that, I think, is the main differentiation between other fields where a lot is talked about, what's the best solution, what is the best thing we can do. In engineering, we talk, we have this saying that the best is the enemy of the good. So good is enough to a certain extent. And that's what we seek. So we seek good enough solutions, which is not necessarily worse. It's just, but I think it's a different paradigm, a different approach to the problem.
You do this in an international group these days as well at SimTech, and you work in a lab that is called ELLIS. May I ask you to tell us also more about that one? And actually, did the lab already exist prior to your joining here at the university, or did you bring it with you?
Yeah, there are three things that I think are important. ELLIS is one of them. So ELLIS is the European Laboratory for Learning and Intelligent Systems that was created much before my arrival to Stuttgart, and in particular the ELLIS unit, which is a unit of this European lab, which is a international entity, was created before my arrival. I was invited to integrate it when I moved here because of, I think, in terms of methodological alignment and topics, right? So this is one thing. The other thing that you mentioned, which is important as well, is SimTech, which is the simulation center here, of which I am also part. And that, I think, is, for the things that I do, very interesting, because this is really a transdisciplinary organization that involves a lot of scientists as well as people working in methods. And I think this is a very rich environment for doing work. And more recently, my group also joined the AI Institute, which is very recently founded at the University of Stuttgart as well, as an associated group. Again, because a lot of the things that I do, I think, resonate with some of the ideas that or some of the topics that are there.
So was ELLIS really a trigger point then for you to come to Stuttgart? Was it decisive in your, when you looked around for positions? You have various experience at universities abroad. What in particular inspired you to come to Stuttgart?
I think the combination of ELLIS and SimTech is a very fortuitous one, and it's very good for the specific work that I do, let's say, which is, like you mentioned earlier, a bit more theoretical. And that I think fits very well within ELLIS, which is really a very broad organization. But the way I see it, for me, it's my theoretical home. It's where the methods that I used come from or are at home at, let's say. And I think that the combination of ELLIS with SimTech, which really is perhaps a little bit more about an actual problem, which is these simulations in modern times, and how do we tackle these challenges that exist in simulation technologies. These provide very good applications for a lot of the methods that I develop. I think that combination was very unique to the University of Stuttgart. And at least for me, this was an attractive point to come to be able to exploit both my theoretical colleagues, let's say, but as well as my reach out towards application colleagues, let's say.
Dr. Chamon, when I looked at your research descriptions, I saw that what your focus is on very different or on different forms of learning. And please help me to overcome my confusion in that. First, I saw that there is a term constrained learning. And second, there is semi-infinite constrained learning. And then third, non-convex functional optimization. Please, could you elaborate on these terms and also tell us what role these research topics play in your current work?
For me to answer your question, I think it's interesting for us to take a step back and try to, for me to explain what I mean by learning, which is a very specific word that has a lot of perhaps connotations attached to it that is not necessarily what I work on. And specifically, what I mean by learning is really the solving of problems using data. So rather than building a model and obtaining a solution based on that, we will just obtain a solution by directly interacting with the environment or directly from measurements directly. So to give you an example, based on something that is becoming very fancy nowadays, which are these large language models, right? So if we look at the first chatbot back in the 80s, which I think was actually called ELLIS, which was supposed to be an Adlerian psychotherapist. And that was coded by somebody, a person, that looked at how a conversation typically would go and created a series of rules that made it seem like the robot is actually chatting with you, right? So this is about, to a certain extent, understanding how language and conversations work, creating rules based on that, and then creating the program that interacts with you. Now, if we look at how ChatGPT works, that is not at all how it is constructed. It is not something that a model that was created and then a solution based on rules. It actually looks at a vast amount of text and tries to, based on that text, which is data, come up with how a good conversation would look like or how answers should be. So this is sort of the things that I do, which is really, this is learning. Learning is just solving problems based on data. Now, as you can imagine, going back to the engineering point that you raised before, one of the issues with that is that data is, even if we read a lot of texts, it's hard to interpret exactly what language is just by reading text, right? We go to school to do that before we start reading books. So we are imparted with a lot of prior knowledge before we start trying to understand these things. And the issue with just let's say, throwing a lot of data at and trying to come up with a solution is that there are many solutions that might fit that data. And what is the correct one is very hard to guess. That means that, perhaps ChatGPT understands that when you write 2 plus 2 equal, press enter, it should write a 4 afterwards. But it doesn't necessarily know what 2 plus 2 means. And this means that you don't know if tomorrow, perhaps 2 plus 1 is equal 4 as well. And this is where this idea of constraints comes in. And the way to overcome these type of things, again, as my training from engineer, is to put requirements. These requirements could be of all sorts of things. For example, requirement on understanding what 2 plus 2 means, so some sort of ontological requirement, not just coming up with words. But it could be also requirements such as robustness. When we try to identify whether the picture contains a bird or not, we want to be sure that a leaf that looks like a bird is not interpreted as a bird. And that's a sort of robustness of the problem. Or it might be fairness, which is something that is become increasingly important, especially as this type of learning or artificial intelligence solutions start to reach societal, or let's say start to reach problems with societal impact. Then it becomes increasingly important for things such as fairness or even legality in certain cases to become a requirement. And what I study is how we could go about taking those requirements and embedding them in these data-driven systems.
I got the constraint learning. Absolutely. Thank you. What about the semi-infinite constraint learning?
Now, all the requirements we talked so far have been one or two requirements. So we want robustness and safety and fairness. Those are three requirements. Semi-infinite optimization problems were problems before where rather than a finite number of requirements, we have an infinite number of them. And they are very important because, for example, in the case of robustness, we want not only a leaf that looks like a bird to not be recognized as a bird, but also a branch, but also all possible combinations of images that we could see. And that's an infinite number of images. And this type of problem is tackled in this topic of semi-infinite programming, which is very technical, but it's just to say that there is a trick for us to essentially impose an infinite number of requirements rather than just a finite one.
And the non-convex functional optimization, is that leading too far in our context here for the conversation?
That's how can I explain that? I think that one, I'm going to chuck that one as a theoretical endeavor. It's very important because a lot of the tools that allow the other two that we discussed to be used came out of that project. But really that is perhaps a little bit beyond. The little bit of, let's say, taste that I can give you there is that there are a lot of problems that we try to solve today that look finite or discrete. Pictures is a good example. Pictures are a combination of pixels. They look smooth to us, but they're just really pixels, right? But real images are not. Real images are continuous. And how could we possibly be able to, process this continuous data is a little bit what the type of problem that we're trying to tackle there. But I'm going to say pass on that one because I'm not really sure how to. That's my own limitation. I'm not really sure how to explain that.
Well, okay, passed, absolutely. Try to bring it back for my own understanding, and I hope also for our listeners as well. What you just described about your work in network data analysis and signal processing really appears to have parallels to the research and teaching that I do in literary studies, where we also look at texts and words and how they are constructed and how they go together and what they mean for that fact as well. I wonder, in your understanding, would you say that your field of work has also similarities to humanities and arts? Or at least some or more than one might think of?
Certainly, I think that's a very good observation, and I find myself always seeing a lot of parallels between endeavors that are more in the humanities. from discussions with friends or my family, a lot of whose are more on the humanities, and my own research. And I think that particularly with art, I think technical endeavors, especially in the field of engineering, have a big parallel. And I think there are essentially two things that I want to stress in that case. The first one, I think, is creativity. And I think I don't need to argue that art is a creative endeavor, but I think that ultimately technical problems also have a large amount of involve a large amount of creativity in solutions of problems. And to a certain extent, that's what attracted me to this area as well. Otherwise, it's really like just going through the motions of doing things mechanically. And really, I think research is not at all that type of endeavor. The other thing that I think is perhaps less considered as a parallel is aesthetics. And I think that in art, clearly aesthetics, and when I say aesthetics, I don't mean beauty, right? I mean the visual, which could be a ugly thing that has an importance to certain ugly within standards, right? That has an importance for that line of let's say of art. And I think in science something very similar happens. We for many reasons either go towards solutions that look aesthetically pleasing for us because these are problems that interest us in a certain way. Societally, they look more interesting than other problems. And also, I think there is a lot of, to a certain extent, feel or like intuition that comes out of aesthetics. The parallelism in certain types of equations or inequalities that, sort of seem to be right before we even prove them. And I think this is really it's a really interesting thing, and it gives also, I think, a little bit of a human side to science. Science has this perhaps fame of being really this technical, exact, and objective thing, when really it cannot be. It is made by people, so it cannot be that objective or that sure. And I think that seeing this parallel with art and in terms of both creativity and aesthetics gives a little bit of a human side to science, to also understand that ultimately scientists are people trying to do something, just as artists are people trying to do something.
In your career, you have focused on science and research, but also worked in a company. Now, this comes together in a unique fashion at ELLIS and SimTech in Stuttgart. What would you say? Which lessons or outcomes of your experiences have you brought with you, say from that stay or work at the company as well, that you actually very consciously try to implement in your current work?
I really haven't worked at a company. Perhaps I would say more with a company is more fair to my best. But I think it's a extremely important experience to work with. Work at the industry side of science has very different incentives and goals than work in academia, scientific work in academia. And I think that is very rich combination to have, even though I would never leave myself academia. It's not something that I'm looking to do. I think it's very important to have that experience. And for me, the most important thing that I took out of that I try to bring today to my job is really the idea of how do we talk to other people. People who have different backgrounds, different interests, and different goals than we do. And yet we need to sort of work together. So we need to work together to develop a solution for this specific problem. And I think in academic industry cooperations, there is always a language barrier that happens in between, because even though we might have studied the same electrical engineering and be working on the same problem, we clearly see the problem in a very different way. And this happens also within academia between different fields, going back to the idea when I talk to mathematicians or to physicists or physicists with mathematicians, and even my colleagues, computer scientists, we all have been trained differently. We all speak different languages, slightly different, perhaps dialects of the same language. And that means that communication can break down at any moment. And it's important to acquire, I think, the skill of first noticing that communication broke down, which is harder than it looks like. We always have this impression that we are communicating perfectly, and yet perhaps not. But also how to navigate this communication breakdown. What are the questions that need to be asked to elucidate the correct answers that we need in order to solve the problem? And I think this is a important skill that I would say is increasingly being lost, unfortunately. But it's also a very hard skill, and it's not one that I fully dominate, but definitely my past work with the industry in different positions, I think have helped me understand a little bit better how to navigate these moments where we need to talk to somebody that perhaps doesn't have the exact same background as we do, and we need to somehow translate their vision into our language and our vision into theirs. And I think there's a lot of work there, but it's also where there is perhaps most room for improvements in any solution. It's at the interfaces. And this is exactly where it takes more work, because it requires you to somehow learn a little bit of the other person's and for them to learn a little bit of yours. But to a certain extent, I think this is a lot of what machine learning and statistics is today. And give an example, at the University of Stuttgart, what SimTech is a lot about. It's bringing these very different people who work from numerical methods in differential equations, pure mathematicians perhaps, towards people who use those differential equations for actual problems, to engineers, to computer scientists. And all these people somehow need to work together if we are to actually solve the problem of creating the next simulation technology, let's say. So I think this is definitely something that I discuss a lot with my students. This is definitely something that I bring a lot to my day-to-day from my past experiences in industry.
I take that word, past experiences, very gladly. You were a bachelor and master student at the University of Sao Paulo. You were an exchange student at the École Centrale de Lyon. And for your PhD in electrical and systems engineering, you went to the University of Pennsylvania. You were also a postdoc at UC Berkeley. And then, we heard about it, you worked at a research or project with Embraer. So, given all of these different steps, or how shall I say, periods, milestones, whatever you prefer, in your academic career and the professional career, can you reflect about one episode, perhaps at one of these institutions that really shook you up, that influenced you very much, and where you drew a very personal or professional conclusion?
Okay, so if I have to pick one event out of all of these, I think it would definitely be one event that kept recurring throughout my life, and it has to do with culture, and that's culture shock, essentially. And growing up in Brazil, living in France as a kid, moving to Germany now for a year, having lived 7 years in the US almost. I think every time that at least myself, when I arrive somewhere, I feel that there is this first knee-jerk reaction of simply rejecting the way things work at any place, because we are used to something. I am used to something different. I think, because of the way I was raised, very differently than people think here. And that means that the system here is set up in a way that I cannot understand. And I think this is a feeling, to a certain extent, that with time we get used to things. We start to understand better the reason why things are like they are, or we get used at least to the thought processes that went into how things are set up. But it also never completely goes away. And I think that's a very positive thing. I think that, change is made by people who refuse to accept things as they are. I think that's George Bernard Shaw, but I'm not sure. These things get attributed to the wrong people all the time. But so I always have this little thing nowadays that I keep to myself to a certain extent, where I decide what are the things that I will accept that I need to change to adapt to, and what are the little battles that I will never give up on. And some of them are completely personal battles. It is very common in academia in Germany to clap by knocking on the table. I refuse to do that. Out of a complete sense of, of no reason. There is no reason. It's my little battle. I don't clap loudly. I just clap in my corner. But this is my way of saying, I am not from here. I don't think it bothers anybody because I'm also not showing it off. But this is my little thing that I keep for myself. And I think it's very important for us to, at the same time, have these little things to keep to ourselves, at the same time as we obviously, for bigger things, try to both understand and adapt to the system, but also adapt the system to us. There is a Brazilian singer that has a song that says, eu não vim para explicar, eu vim para confundir. I didn't come to explain, I came to confuse. And I think this is, in the end, a little bit what we live nowadays, right? I mean, after all of this international experience I've had, and I think, as the world as well becomes more and more international, more and more globalized, it is important that we all understand that we all came to confuse each other and not necessarily to explain. And in that confusion, hopefully, make something that that is better than the sum of the parts, right? And that requires everybody to work with everybody. We don't need to agree or even to adapt to each other. We just need to work together to a certain extent. And I think that's the one event that kept happening over and over. And I am still not used to it happening. It still bothers me. It's still, I think it's a very stressful thing. But I wouldn't give it up. I think those are amazing experiences to be able to live in different cultures and different things. Yeah.
Thank you for that explanation. Not confusing at all, making a very good point, I think. You have not given up a couple of things, I guess. You are interested in music. You play several instruments. I think as far as Brazilian music is concerned, it's you were at once a member of a Foro band. Foro. So you can tell us about that perhaps a little more. You also produced music and also international theater plays. You speak a couple of different languages, including Greek, and you play soccer. To me, that's a very impressive range of activities. Given your busy calendar at the university and academia already, these days, which of the ones is the most important to you?
I would say that I pretend to do all these things more than I actually do them. And I think that I pretend to varying degrees of success. For example, I pretend to play soccer and it's a complete failure. I am actually very, very bad at that. I pretend to speak some languages, some of them pretty well. Greek is one that, more or less, it's still a work in progress. I don't even pretend to speak German, so to avoid any confusion. As far as music goes, I always like to play a lot. I never was very attracted by any particular instrument, but for the most part, what I play is really the piano and the guitar, I would say. Those are the ones that I pretend the best. The rest is just there in the list because it's in the list. I started to get interested into electrical engineering and signal processing because of music. And that's somewhat of a well-known story. It's quite common, actually, for a lot of signal processing people to have started in music. But I don't know, it just combined two of my passions to a certain extent, which was, technical math and music.
And it came also in quite handy during co-pandemic times, I think. You published a song, or more than one song, I'm not even sure, in 2020 in Greek. And how did that come about?
Yeah, it came in handy twice during the pandemic. First, because all the conferences were online and we needed to make videos and recordings for everything. And I was already prepared for that. So, it was worth spending those hours when I was a teenager playing around or walking around in studios back in Brazil. And it came about because obviously during the pandemic, I think a lot of us during the pandemic got to different hobbies, and I came back to my hobby of recording music. And one of the challenges that I placed to myself in 2020 was to record a song in Greek. It was a language that I was learning at the time, and it was a good way for me to, sort of incentivize myself to write, to do something, and to have sort of a milestone to walk towards. And so it took a little bit longer than 2020. The song came out in 2020, but the album really only came out a few years later when I was in Berkeley last year, actually in 2022. And this is just a compendium of a incredible total of 3 songs that I managed to record before in between finishing the PhD and moving to Germany. I think to a certain extent is what we talked about. Art and science have so much in parallels that it's really a great opportunity to be able to do both, and to see those parallels and to try to evolve or bring ideas from one into the other. And I think that's part of also why I like to do of these both things at the same time. Even though, like you mentioned, the time to do both of them is quite restrictive. So it's hard to find time to do everything. But I think a little bit of everything we can always try to.
Dr. Chamon, thank you again for having explained your view on the relation between arts and science, or science and arts, whatever, in whatever order you would like to put it. Now, I would like to come back to science and ask you what's upcoming for you in your research life next.
So the next thing coming up probably now in a few weeks is our tutorial on constrained learning at AAAI in Vancouver. So that is happening end of February. So we'll be giving a half-day tutorial about all the topics that we mentioned today. So if you are interested in learning about constrained learning, you can come visit us in Vancouver. More broadly, my work goes on at ELLIS and SimTech and the University of Stuttgart with my students. And honestly, I'm not sure what's next, and I think that's a good thing.
For sure, I know what's next, and that's our moment 7. We have collected 7 questions that we would like to ask you, and please answer them as shortly as possible. Moment 1. Spätzle or Maultaschen?
Maultaschen.
Moment 2. One thing you could change about the world.
I think we could all use a little bit less seriousness.
Moment 3. Since you also play music, would you have a recommendation for us?
So I am going to give you a slightly different recommendation, which is to go see a movie, and rather than listening to music, which is called They Shot the Piano Player. It's a movie that came out this year from a Spanish movie about a Brazilian piano player that was kidnapped and disappeared in Argentina during the dictatorship. And he was one of the most virtuoso piano players in Brazil. He was playing with Vinicius de Moraes at the time when he disappeared. And the movie is actually a documentary. It's an animation documentary that interviews a enormous number of Brazilian superstars of Brazilian music, really, from Milton Nascimento to Vinicius de Moraes. Belbo Valdez shows up at some point. It's an incredible movie about a really sad part of Latin American history. I think it's very nice.
Moment 4. The best advice that you have ever received was?
Keep putting one foot in front of the other.
Moment 5. Your favorite place on campus at the University of Stuttgart is which one?
I really like my office.
Moment 6. Please finish the sentence. If I could start all over again, I would do the following differently.
If I could start all over again, I would have learned German before moving to Germany.
And finally, moment 7. Also, complete this sentence. Thanks to my studies, I know that...
Thanks to my studies, I know that I don't know anything.
But that we know a lot of. Thank you so much for our conversation today. Thank you for your time. Thank you for letting us share some of your thoughts about the field that you work in, but also about academia in general, the relation of arts and science. And I felt today a little bit about the human situation in general as well.
Thank you very much. I really appreciate the invitation and the opportunity to be here. And thank you for asking me these hard questions and for giving me the opportunity to try at least to articulate some of the scientific and non-scientific aspects of my experience here.
You are very welcome. And to our audience, please stay tuned for our upcoming conversations that are always based on what is made in science. My name is Wolfgang Holtkamp. Have a great podcasting day. Goodbye and good talking.